Pull up any weather map for the UK right now and look at the color they are using. Not red, not orange, not the amber that British weather watchers have learned to associate with serious heat warnings. On some of the temperature forecast maps now circulating from meteorological services, tracking this week's incoming heat, the deepest reds have given way to something darker, a near black shading that represents temperature ranges. These maps were not originally designed to show for the British Isles in May. This is not dramatic graphic design. This is what happens when a computer-generated weather map applies its standard color gradient to a temperature forecast that falls above the range its designers considered necessary for late May in England. The gradient runs out, the color runs out, and what you are left with is a map that looks, in its darkest shaded zones over southeastern England, Essex, Kent, Surrey, and the Thames corridor, like something generated for Morocco or southern Spain, not for a country that was dealing with snow on Dartmoor and ice on Norfolk's flatlands less than 2 weeks ago. What is coming for Britain this weekend is something the Met Office has now formally confirmed will break records that have stood for 36 years. Steve Coker of the Met Office stated it without qualification. It is likely that the May and spring UK temperature records will be broken over the bank holiday weekend, with forecast temperatures surpassing the existing record of 32.8 degrees Celsius. That existing record, 32.8 degrees set in the spring of 1990, has survived every warm May and every early summer surge since. Margaret Thatcher was still Prime Minister. It survived the record-breaking Mays of the 2010s. It survived the summers that produced 38 and then 40-degree records in recent years. And it is now expected to fall. The forecast is 32 degrees Celsius by Sunday in southern England, and that is the conservative end of what the models are showing. Because beyond this weekend, the atmospheric pattern does not simply cool off and return to normal. What arrives after the bank holiday weekend in the final days of May and the opening week of June is the event that is generating the genuinely alarming black weather map colors, the African plume, and its potential peak sits not at 32 but closer to 35 degrees Celsius, a temperature that, in May, would be completely without precedent in the entire British meteorological record. Before we track the full sequence of what is coming, county by county and day by day, it is worth understanding exactly what an African plume is. Not the tabloid shorthand, but the actual physical mechanism, because understanding the physics tells you why this particular heat event is categorically different from the homegrown warmth that already broke the May 1st record earlier this month. On May 1st, 2026, temperatures at Kew Gardens in London reached 29.3 degrees Celsius, shattering the previous record of 27.4 degrees for the first day of May set in Lossiemouth, Scotland in 1990. That warmth, as the BBC and the Met Office both explained at the time, was generated by high pressure sitting directly over the UK, allowing clear skies to warm the air through sunshine without any particularly exotic air mass origin. The Met Office explicitly described it as homegrown warmth, air that originated locally within the anticyclone rather than being transported from further south. London was hotter than Athens, Cairo, Marrakesh, and Los Angeles on that day, but the heat source was British. What arrives at the end of May and into June is something entirely different in its provenance and its intensity, and the difference matters enormously for how high the temperatures ultimately go. An African plume is a meteorological event in which hot air masses from the Saharan interior of North Africa are transported northward through the upper atmosphere toward Europe and ultimately toward Britain. The mechanism requires a specific atmospheric setup to function. First, an area of intense high pressure must sit over the western Mediterranean or the Iberian Peninsula, the Azores High, or a connected ridge extending toward southern Europe. That high pressure drives southerly and southeasterly winds through its eastern flank, establishing an airflow pathway from the Saharan interior northward through Morocco, Algeria, or Libya. The air in the Saharan source region can reach 45 to 50 degrees Celsius at the surface in late May and early June as the sun angle increases and the desert heat builds to its annual maximum. As that air travels northward, it rises into the middle and upper troposphere, the layer of the atmosphere from roughly 5,000 to 10,000 meters above the surface, and is transported at altitude across the Mediterranean Sea. During its sea crossing at altitude, it does not significantly cool. The Mediterranean waters below are warm in late May, and the air is moving quickly enough at altitude that surface exchange is limited. The air then descends on the northern side of the Mediterranean as it approaches southern Europe, warming further as it compresses during descent. By the time it crosses France and the English Channel and arrives over southern England, it is carrying a thermal signature that reflects its origin thousands of kilometers away in the Saharan interior, rather than anything that the North Atlantic or the British climate system generated locally. This is why African plume events consistently push UK temperatures into territory that high pressure sitting domestically over Britain cannot reach. The source air is simply hotter, drier, and more energetically extreme than any air mass the home climate can produce in May. The forecast for the final week of May 2026 involves exactly this mechanism, activating at a scale and intensity that multiple independent weather services are calling genuinely exceptional. The high pressure that delivered Sunday's potential 32-degree reading is the atmospheric precursor. It establishes the ridge pattern that then draws the southerly flow northward from the continent. As that ridge evolves and deepens through the final days of May, the southerly wind trajectory shifts to pull air from progressively further south. By late May 24th and into May 25th, forecast models are showing the Plume's hottest axis, the narrow tongue of most intense Saharan air, tracking directly over the 10 counties that form southeastern and southern England's most heat-exposed zone. Those 10 counties are London itself, treated as a county equivalent. Administrative area. Essex, whose Thames-side communities and flat agricultural interior are among the most reliably extreme heat locations in England. Kent, whose sheltered inland valleys regularly outperform coastal areas in heat events. Surrey, whose suburban and rural combination frequently records the highest afternoon peaks in England. Hertfordshire and Bedfordshire, whose inland position away from any coastal cooling maximizes the heat dome effect. Cambridgeshire, which recorded some of the country's most extreme temperatures during the 2019 event that broke the previous all-time record at Cambridge Botanic Garden. Suffolk and Norfolk, whose flat eastward facing terrain draws the southeasterly plume air inland without terrain obstruction. And Hampshire, including the Solent Coast, which regularly features in extreme temperature records during southerly events. The progression of temperatures through the weekend and into the following week tells a story of escalating heat that the Met Office and LBC's weather analysis have now documented in specific detail. Friday, May 23rd, delivers the thunderstorm bridge between the previous pattern and the incoming heat. Yellow weather warnings are in place for London, Wales, England's east and southeast, the West Midlands, and England's east and southwest for overnight Friday into Saturday, as the Met Office identified a risk of beefy showers and humid, thundery breakdown of the previous week's warmth. That breakdown is not the end of heat. It is the atmospheric gateway through which the African plume air mass enters. When the thunderstorms clear through Friday night, they leave behind a washed atmosphere with reduced cloud cover, and it is into that cleared, moisture-reduced atmosphere that the Saharan air descends on Saturday and Sunday. Saturday sees 30 degrees Celsius reached across southern England. Brighton Beach is already reported to be packed to capacity by morning, as families take advantage of the warmth that a week previously would have seemed impossible given the snow that fell on Dartmoor. Sunday is the record smasher. The Met Office's Steve Coker places 32 degrees Celsius as the expected peak across southern England on Sunday, surpassing the 32.8 degree spring record. And with the African plume's hottest core air still arriving, some models show isolated locations in the sheltered inland valleys of Kent, Surrey, and the Thames corridor nudging toward 33 to 34 degrees before the day ends. The existing 29.3 degree record set on May 1st at Kew Gardens will by this weekend look like a warm-up act. London was hotter than Cairo, Marrakesh, and Los Angeles on May 1st. By Sunday, May 24th, the gap between London and those historically hot cities will narrow further still, because Cairo's maximum in late May sits around 36 to 37 degrees, and London at 32 to 33 is approaching that range. When a British city records temperatures in the same ballpark as the Egyptian capital in May, the phrase May Mayhem begins to feel less like tabloid invention and more like genuinely accurate description of a month that opened with Arctic snow on Dartmoor and ends with the warmest May temperatures in the history of British meteorological measurement. What happens in the days following the Sunday peak, from May 26th through to the first days of June, is the window that has meteorologists and independent forecasters watching their model outputs most intently. The thunderstorm risk that cleared through Friday night does not disappear permanently. As the African plume's hottest air sits over southeastern England in the extreme temperatures of Sunday and Monday, atmospheric instability begins to build from the ground upward. The intense surface heating creates vigorous convective cells, parcels of air rising rapidly from the superheated surface, cooling and condensing at altitude, and potentially generating the kind of deep, violent thunderstorm towers that British weather observers call thunderstorm cells, and that produce lightning, large hail, and rainfall intensities of 30 to 50 millimeters per hour in localized zones. A thunderstorm delivering 50 millimeters of rainfall in an hour onto London's drainage system, designed for far lower intensities, produces surface flooding that closes tube stations, blocks roads, floods low-lying residential streets, and creates the kind of transport chaos that the July 2021 flash flooding events across London demonstrated comprehensively. The risk of exactly this kind of convective breakdown from the African plume air in the late May to early June window has been specifically flagged by independent forecasters. who note that the more intense the heat that precedes a convective storm, the more energy is available to power it. The 2025 UK summer produced the event that most clearly prefigures this risk in recent data. In the summer of 2025, England and Wales experienced 3 confirmed heat waves, with temperatures reaching 33.2 degrees Celsius in Charlwood, Surrey, a new record for that summer, on a Saturday in what BBC coverage described as the UK recording its new hottest day of the year for the 3rd consecutive day. The August 2025 heatwave also generated thunderstorm warnings for London, Wales, England's east and southeast, West Midlands, and the east and southwest, as the Plume air became unstable after several days of extreme heat. In 2025, the sequence of events was precisely the pattern now forecast for late May 2026. African Plume air arrives, establishes extreme heat for several days, instability builds in the overheated atmosphere, severe thunderstorms break out across multiple regions simultaneously, and the combination of flood damage and heat damage within the same multi-day period creates the kind of compound weather impact that insurance actuaries classify as materially different from either extreme occurring separately. The records broken in 2025 are now in serious danger of being broken again in May 2026, just 3 weeks into meteorological summer rather than at its peak. The climate context behind the fact that a month containing snow on Dartmoor and a potential 35-degree African Plume record simultaneously is now considered within the range of normal British May weather is the same context that the Climate Change Committee's landmark report, published today, May 20th, 2026, described when it stated that the UK was built for a climate that no longer exists. The Baroness Brown's committee documented the trajectory with specific numbers. Without action to adapt, heat waves in the 40-degree range by mid-century could lead to 10,000 excess deaths per year. The context for that projection is visible right now in the weather maps. Britain, in the 3rd week of May 2026, has already experienced snow on Devon's moorland and is now preparing for the hottest Mayo temperatures ever recorded. The distance between those two events, measured in time, is less than 2 weeks. Measured in temperature, it is a gap of more than 35 degrees Celsius across the same country in the same calendar month. The climate that produced that range in a single month is not the climate that Britain's housing stock, its road surfaces, its railway infrastructure, or its public health system were designed to manage. The road surface question during extreme heat events is one that consistently catches the public by surprise, and one whose practical implications for travel and safety during the late May heat are concrete and immediate. Bitumen-bound road surfaces begin to soften and deform at sustained temperatures above approximately 50 degrees Celsius at the surface, a threshold that can be reached on dark asphalt under direct sunlight even when air temperatures are in the mid-30s, because solar radiation heats dark surfaces significantly above the ambient air temperature. During the 2022 heat wave, sections of A Road and B Road in southeastern England experienced surface deformation that caused vehicle handling problems and required emergency speed restrictions. Several runway surfaces at smaller UK airports required inspection and temporary restriction. After surface temperature monitoring indicated they were approaching design limits. In a weekend that may see air temperatures of 32 to 34 degrees under strong late May sunshine, road and runway surface temperatures could approach or exceed those critical thresholds in the most exposed locations across the 10 identified counties. The railway network faces a related but distinct vulnerability. Rail steel expands with temperature, and track designers account for this by installing tracks with built-in expansion gaps sized for the expected temperature range of the local climate. When temperatures exceed the design assumptions, rails can buckle, a process called sun kink, in which the rail deviates laterally from its intended alignment, creating a potential derailment hazard. Network Rail responds to this risk by imposing temporary speed restrictions that reduce the dynamic force of trains on the track, reducing the risk of derailment if a buckle occurs. Those speed restrictions add journey time, trigger cascading timetable disruptions, and during a bank holiday weekend when passenger volumes are at their highest, create exactly the kind of travel chaos that generates both operational and reputational damage for the rail industry. The combination of bank holiday volumes and extreme May heat this weekend represents precisely the scenario that Network Rail's operational protocols class as high risk for track temperature management. The 10 counties facing the peak heat of this event, London, Essex, Kent, Surrey, Hertfordshire, Bedfordshire, Cambridgeshire, Suffolk, Norfolk, and Hampshire, together contain approximately 19 million people. Of that population, the UK Health Security Agency estimates that roughly 2.5 million are in the high-risk categories for heat-related health harm. Adults over 75 living alone, adults of any age with cardiovascular or respiratory conditions, young children under 4, and people whose medications impair their ability to thermoregulate. The UK HSA issues heat health alerts at 3 levels: yellow, amber, and red. A yellow alert is triggered by forecast temperatures above the regional threshold for 1 or 2 days. An amber alert is triggered when temperatures are expected to exceed thresholds across 3 or more consecutive days, with a significant health impact expected across the population. The Sunday to Tuesday forecast for southeastern England, with Sunday expected to hit 32 degrees, Monday remaining in the high 20s to low 30s, and the African Plume potentially peaking at 34 to 35 degrees in the warmest locations during the final days of May, carries the temperature profile for an amber alert that will activate the cascade of NHS trust level responses, social care check-in protocols, and public cooling centre communications that the UKHSA's Heat Health Framework prescribes. There's a dimension of the late May 2026 heat event that sits precisely at the intersection of all the themes that have defined Britain's extraordinary weather year so far, and it is worth stating plainly as this script approaches its conclusion. 12 days ago, the Mountain Weather Information Service was issuing forecasts for snow and overnight temperatures of -1 to -3 degrees Celsius on Scottish mountain summits. The same weekend, Devon's Dartmoor received wintry showers that constituted one of the most southerly May snowfall events in the modern meteorological record. The same country, on the same weekend that those Scottish summits were under snow and frost warnings, saw the Climate Change Committee publish the most comprehensive and urgent assessment of Britain's climate vulnerability ever placed before a government, stating without ambiguity that the United Kingdom was built for a climate that no longer exists. And now, less than 2 weeks after the snow and 12 hours after the CCC report, weather maps are showing near black shading over southeastern England for temperatures that the standard color gradient was not designed to represent for this country in this month. The meteorological summary of what arrives this weekend and through the final days of May is straightforward. Saturday delivers 30 degrees and the first beach-packing heat of the year. Sunday delivers 32 degrees and breaks the spring temperature record that has stood since 1990. The days after the bank holiday deliver the African Plume's hottest pulse, the air with its Saharan origin, its 1,000-kilometer transit across the Mediterranean, its descent over France, its crossing of the Channel, its arrival in the 10 southeastern counties where the background heat island effect, the shelter of inland valleys, and the absence of any oceanic moderation allows the temperature to build toward the 34 to 35 degree range that would make late May 2026 not just the warmest May in the British record, but one of the hottest any month has produced in England outside of the summer solstice window of June through August. The black on the weather maps is not a display error. It is the atlas of where Britain now lives, in a climate that surprises even the meteorologists who track it, in a month that can contain both winter and something approaching the Sahara within the same fortnight, in a country that was warned is being warned, and will be warned again as the maps keep producing colors that the designers never planned to need.